This lesson is on evaluating polynomials. When we evaluate a polynomial, essentially what we're doing is we are plugging in whatever value they give us for x in the function to find out what f of x is, or h of x, or essentially what y is. So a few things here. H of x, this is function notation. It simply means that it's a polynomial where I'm going to plug in a value for x to find h of x, which is what we're used to looking at as y. So when I plug in that value, I'm essentially replacing every x with the value that they give me. So in this example, I'm finding h of 3, which means I'm replacing x with 3 and x with 3 and x with 3. And then I'm just going to follow the order of operations. The order of operations says that first I do parentheses, which I don't have any parentheses to evaluate, but I do have some exponents. So I'm going to evaluate 3 to the 4th, which is 81. And I can also evaluate 2 times 3, because then that's multiplication, but notice it's separated by a plus sign, so it's legal for me to do that. So I have -2 times 81 plus 6 minus 3. Again, order of operations says I multiply before I deal with the plus or the minus. So -2 times 81 is -162. And then I'm simply going to add -162 plus 6 and then subtract 3. And there's my answer of -159. So let's look at both of these together. First, I'm going to replace every x with 2, so 5 times 2 to the 3rd plus 3 times 2 minus 9. Now again, I want you to notice that when I plugged in the 2, I'm plugging it in parentheses, and you might see some people plug it in like this, and these two things are exactly the same, whether I have this exponent here on the inside or on the outside. Just keep in mind that only the 2 is to the 3rd power. So please don't take 5 times 2 to get 10 and then take that to the 3rd, because this is x to the 3rd power. So this is now 5 times 2 to the 3rd, which is 8. I can go ahead and take 3 times 2 to get 6. I'm then going to multiply 5 times 8 because I have to do that before I add or subtract. So I get 40 plus 6 minus 9. Going from left to right, 40 plus 6 is 46, minus 9 is 37. For my second function, I'm finding g of 3, and g of 3 means I'm replacing x with 3. And so again, I'm going to do exponents first, evaluate my exponent. So 3 squared is 9. Everything else just gets rewritten. -2 times 9 is -18. If I add -18 to 3, I get -15. If I add 8 to that, I get -7. So that's my final answer. Again, once it's addition or subtraction, you just go left to right. Go ahead and try these two on your own, then press play to see how you did. I gave you a couple of tricky ones here, one tricky and one not so bad. For my first one, f of -1, I'm replacing, again, x with -1. And the reason I like a question like this is because 1 doesn't really change anything, and the negative just screws us up with exponents and makes sure we know our rules for exponents. So for my first one, if I take -1 to the 4th, that's -1 times -1 times -1 times -1, and that 4 negatives make it a positive value. For my next term, -1 to the 3rd, that's 3 negatives, which means when I multiply it out, I do get -1. And this last term is where most people get thrown off, because I have a minus here, and when I multiply 2 times -1, I get -2, so I'm subtracting a negative value. Again, for anything where I subtract a negative value, I would leave change opposite or keep flip change or ching ching or whatever mnemonic device you're helping yourself to remember that rule. You could even do it up here on this step so you remembered it was a negative times a negative to make it positive. Now I have 2 times 1, which is 2, plus 3 times negative 1, which is negative 3, and then plus 2. When I combine those together, I get 1. And for my last one, I'm simply replacing everything with 0. And what I know about 0 is that anything times 0 is 0. So on this one, it doesn't matter if I take 0 to the 5th because 0 to the 5th is 0. And if I take it times 16, that gives me 0. 0 to the 3rd is 0. And 8 times 0 is 0. And so my answer is 0.